Today we have Nick Keemster. He's a professor at Georgia Tech and my advisor. He has done a lot of work in network management and most recently in network security as well. Spam is something that is close to his heart, and he'll be talking about that today. So without further ado, Nick Keemster.
Thank you. Thanks for joining me today. Today I will, as Makar mentioned, I will be talking about spam, and more specifically, I'll be talking about filtering spam and what we think is sort of a new complementary approach. Of course, we all know about spam. You guys probably have more of it than me, or even all of us at Georgia Tech. Of course, various reports, depending on what you read, indicate that this constitutes anywhere from 3/4 to as much as 95% of all email traffic. More troubling than the increasing trends are also that the medium by which spam is sent itself is also becoming increasingly diverse. Spammers are getting more creative in terms of how they send spam. We've seen images and PDF spam, starting to see MP3 spam, Excel spam. It's also becoming more targeted. Content filters I guess vanilla content filters can't catch these things. Of course, there have been various types of plugins that try to do things like OCR on images, et cetera, but this is quite tough. It's more than just a nuisance as well. Seeing more and more beyond just things that cause you to want to hit the delete key. There are other things that may trick you into revealing personal information, banking information, what have you, in the form of phishing attacks. So I won't talk too much about phishing today, but some of our research also looks at similar techniques to what I'm going to describe today for countering various types of phishing attacks. As I mentioned, also these attacks are becoming more targeted. So now, of course, there are a wide variety of things that we can actually do about spam. I'm going to talk about specifically one type of approach, right? There are other things that have been proposed, of course, ranging from charging to sender domain keys to all sorts of other things that I'm not going to talk about today. Just going to focus on this one type of approach, and in that line, I'm going to describe a new or fairly complementary approach to what people have done in the past. So let me just give you a brief overview. Filtering, of course, is basically just exactly what it sounds like, right? Just stop the unwanted traffic from getting to me, right? Keep it out of my inbox. And there are many ways, of course, that you can actually do that, right? So you can start to ask what types of features best differentiate things that users don't want from things that they really want to read, right? So you can do this in a number of ways. The first two are fairly conventional approaches that have been in use for quite some time, right? So content-based filtering, something we already talked about a little bit, right? This is just what's in the mail, right? Can I tell based on what's in the message itself whether or not this is something a user is likely to want to see? Another approach is essentially reputation of sorts, right? What is the IP address of the email sender, right? And if I have previous information about that IP address, I can say something about whether or not the message that's being sent from that sender is likely to be spam or not. Both of these approaches, as I mentioned, are not new. They have various advantages as well as some shortcomings that I'll talk about. The third is actually what I'm going to spend most of the time talking about, which is another type of thing that we can filter on, which is behavioral features, right? Can we look at how mail is being sent? And in particular, can we look at features about how it's being sent that we can see from the network traffic? That is, without actually looking into the messages themselves. Just by looking at traffic patterns, can we develop some ways to infer whether or not a message that's being sent is likely to be legitimate or not? So before I get into the details of what we've done, let me just sort of briefly summarize some of the shortcomings of some of these other approaches, right? So content-based filtering, and let me be clear here, with this work, we're certainly not advocating replacing these other techniques, right? What I'm basically advocating are new techniques that are complementary to these. So content-based filtering, of course, has its place, but there are some problems, right? So for one, spammers can alter the features of what's actually in the contents of the mail, customize it per recipient, et cetera, make it very difficult for a specific type of content rule to be able to differentiate between spam and legitimate mail. On the flip side, anyone who's maintaining a spam filter has to continually update the capabilities of that content filter so that it can, for example, when a spammer decides that he's going to send a message in MP3s today and PDFs tomorrow, then whoever's maintaining those filters basically has to keep up continually with being able to parse various types of content. Okay, I'll get into some more details later about sender reputation, or what if should we just use the IP address of the sender to try to differentiate between legitimate senders and spammers? Well, that actually has seen some success and is fairly used in a fairly widespread manner, in the form of things like Spamhaus, but also their commercial sender reputation systems as well, put out by Secure Computing and Ironport, and some of those folks we're actually working with in terms of improving some of these reputation systems. But one of the drawbacks is that if you've never seen an IP address before, you may not actually know what to do with it, right? There's no reputation, good or bad, about that sender. There are other problems as well. But from our data alone, we do see, on any given day, we see about 10% of the spam hitting our spam traps, or 10% of the senders sending that spam are coming from IP addresses that we have never seen before. So even if you had the perfect reputation on IP addresses that you'd seen before, there's still a fair number of senders that that are cropping up new every day. So there are various causes to that, and actually I don't have a definitive answer for why we're seeing that. Possible explanations could include that these are botnets that are on dynamically addressable subnets. Others might be that they're newly infected machines. I don't know why this is happening, but bottom line is that it is, so that if you just had a static list of bad senders, well, that's maybe not going to work as well as you would hope either. Okay, so here's sort of just a brief summary of this third way that I'm going to spend most of the time talking about, this third way of actually filtering. So what if instead we just talked about or tried to filter email messages based on how they were sent, right? What do I mean? Well, let's look at sort of network level properties, right? So where is that email coming from in terms of its hosting upstream ISP? Can we tell if we have additional information, or if we can make a guess, is this part of a coordinated group of senders, right? Does this sender sending behavior look much like other senders sending behaviors, thereby indicating that it might be part of a botnet, for example? Other things that we'll look at: how far has the message traveled? So we can take IP addresses and map them to geographic locations and say, okay, what's the distance that this message has traveled? Turns out, actually, as we'll see, that's actually fairly good property that you can use to differentiate as well. Another one would be, who has this particular sender talked to in terms of recipient domains, right? So is this IP address just talking to Google, or is it talking to some set of domains that looks unusual or weird, or unlike a set of recipients that a legitimate mail server might actually be talking to? So those are the types of things that we're going to be looking at, and I'll describe later in the talk how we are building those into a classifier. These are just a very small set of examples, and this is kind of an ongoing challenge, actually. maybe you also have some answers to this as well. But this is something that we're continually digging for, is like which of these features are most useful for distinguishing his spam from legitimate senders. OK, so here's kind of what I want to do for the rest of the talk. I want to give a brief overview of a study that we did several years back now on just basically a characterization study of the network level behavior of spammers. So I'll briefly describe what we did, and I'll talk about some of the highlights there. I'll skip a lot of the sort of mundane statistics, which you probably also have, and you can grab out of our SIGCOMM paper if you're particularly interested in those. But I'll stick to some of the more surprising findings. Then I'll talk a little bit about sender reputation systems, in particular IP blacklists or DNS-based blacklists, as they're also known. And just to look at sort of how well are those sort of sender-based reputation systems doing today from what we can see in our data. Then I'll talk about specifically a little more about this behavioral-based network filtering that we're working on, and I'll describe what our current results and where we are. OK, so let me first just briefly describe some of the results and some of the study that we did just to study the network level behavior of the spammers. So what we did in this study, which actually was quite some time ago now, was for almost a year and a half, what we did is we set up a spam trap. By that, basically, what I mean is we set up a machine that was the mail exchange for a couple of domains for which there were no legitimate email addresses, right? So we knew that anything coming to, trying to send mail to those domains was essentially a spammer, because there was no one there that anyone would actually want to talk to. So typically, like, standard mail server would basically just reject this, right, or drop it silently. What we did then was actually just to accept any. So if any spammer was trying to talk to us, we would accept the mail for delivery and say, yeah, OK, that user exists. Sure, we'll happily take that. We also did a bunch of other things in terms of active measurement, which I'll describe on the next slide. That mail server was a little bit special. But the other thing that we did, or the other thing that we collected at the same time, was routing information. So here at the border, actually, we set up a I won't get into routing details in this talk, but it's basically an internal BGP session, which allows us, bottom line is down here, what we can see is, here's what the internet routing table looks like at the time we got this particular piece of spam. So we can now start to ask questions about reachability, network level reachability, in regard to the spammers who are hitting the trap. That actually turned up some pretty interesting findings, which I'll get to in just a minute. So the server itself that we used, the MTA, was something called Mail Avenger, which came out of Stanford, actually. What it allows you to do is actually gather a whole bunch of other additional information. It's fairly configurable, so you can write scripts on various things that perform various operations on the header as the mail comes in, gather additional information. So other things that we grabbed were things like the SYN fingerprint of the sender. So that allowed us to do things like gather statistics on likely operating systems of the people who were spamming us. The other thing that we gathered was, at the time the mail came in, we performed blacklist lookups into about 7 different real-time DNS-based blacklists. So we could see, OK, at the time this particular IP address hit us with spam, was it listed in any of these blacklists? And how many of the blacklists was it listed in? So then we can ask questions about, how well are these blacklists doing at blocking these senders? OK. So we have all this information, and then we had all the routing information. So then we could actually do some joins on that, and we found some pretty interesting things. So this is a bit hard to see, but I'll draw it out for you. So basically, what I have here is a timeline. This is about 15 minutes. And what we see here is actually a new IP address space being announced. Okay, so this is a BGP route advertisement that we saw at our monitor for some portion of IP address space. Okay, then a little bit later, we start to see spam trickling in from IP addresses that are in that space that just previously was not even in the routing table. So this space recently, recently became reachable, and then all of a sudden we're seeing spammers hit us from that IP address space. And then a bit later, in this case about 10 minutes later, we see that route go away. Okay, so that address space is no longer reachable. If you go look at the paper, and the end of the talk has some references, there are other patterns of announcements and withdrawals and spamming, but this is one. Interesting. Well, so there's several interesting features to this particular behavior. One is that it's fairly short, and for most of the time, the prefix that's being announced is nowhere to be found in the table. So that actually, if you imagine you're a network operator that's trying to actually trace back to some of these IP addresses that are sending the spam, that actually makes it a little bit more difficult to trace, particularly if you're not looking at the BGP route announcements themselves. We actually tried testing the reachability for some of these IP addresses, and they were in fact gone when we looked later. The other thing actually that's actually quite interesting is what prefixes are being announced in this manner. So I should mention before we go on that this is not something that we saw that was predominant in terms of the volume of spam. So this was not something that, say, lots of spammers were using, but we saw a small group of spammers continually using this over the course of many, many months. So getting to the question of these prefixes, actually, so just to go back, we saw a lot of these prefixes advertised in this way that were as big as /8s, right? So 1/256 of all the internet's IP address space being announced by a spammer in this way seems a little strange until you think about exactly what's going on, right? So imagine you're a spammer and you need new IP addresses. Well, one way to do it is, or one way to get these IP addresses is to steal them in this way. But if you didn't want to disrupt other traffic, right? So the point of this route hijack is not to, cause havoc, but to silently suck up unused IP addresses. Then using big prefixes is actually going to work pretty well, right? So. For one reason, actually, if you use a shorter prefix like this or something that's more IP address space, typically not going to be filtered, right? If you try to steal a smaller chunk of IP address space, like longer than a /24, for example, that route may be filtered. The other is you get this really nice flexibility, right? So you can actually take if you're a spammer, you could actually take a fairly large space, and it doesn't matter if there are other ISPs that are actually routing some subset of the IP addresses within that space, right? You can actually go around them and take up other dark space that's not being routed, because those pieces of address space that other ISPs are routing within there will still continue, those routes will still continue to work, right? Longest prefix match will still ensure that any other more specific routes that are already being announced inside that /8 will still operate as normal. But any IP addresses that are not being used are now happily snapped up by a spammer. What we saw actually in terms of the actual IP addresses within that space are fairly consistent with this sort of agility, right? Sort of taking up a big amount of space and then hopping through dark areas that are not used. So we saw within that space, the IP addresses that were hitting the spam trap were fairly distributed across the space. They weren't being routed by anyone else. In many cases, they weren't actually allocated to a specific ISP. They may have been allocated to a registry, but they were, for all intents and purposes, not being used. The other thing we saw was for this particular mechanism, the IP addresses that were hitting the spam sinkhole typically only hit it once, right? So we'd see many IP addresses from that space hit the trap, but never the same IP address twice. So that's also consistent with this, this hypothesis that the spammers are hopping through the space. Also sort of consistent with the untraceability goals that we think that the spammers may be trying to achieve with this mechanism, we actually tried to trace route to many of these IP addresses later just to see if we could get there, and sure enough, we couldn't. The other thing, so I briefly mentioned this, but this is actually worth noting as well, right? So you might think, okay, well, why not just take a /8 that's not allocated? Well, in those cases, actually, those routes might in fact be filtered. So by hijacking a route or announcing a route that's actually been allocated to a registry, it's much less likely that the route will be filtered. There are other things that we saw as well that are sort of more detailed in the paper, and then the paper also includes various statistics, which these days are probably not super surprising. But for example, almost 90% of the spam that we saw at the trap was coming from Windows hosts, according to those SYN fingerprints that I was mentioning. Not particularly surprising in light of the fact that we know that a lot of spam is coming from botnets. Okay, so next question that I want to look at is, how well are these IP-based blacklists actually working? We know that there are many of them out there, Spamhaus being a predominant one. How well do these things actually work, right, in terms of sender reputation? So when asking that, we can sort of ask that question in terms of two metrics. One is completeness, right? So that's essentially, are these IP addresses actually listed in the blacklist at any time, right? Do they show up ever, right? The second is responsiveness, right? That's, well, okay, this IP address eventually gets listed in the blacklist, this spammer, but how long does it actually take, right? So this is important because if it is in fact the case that these spammers are hopping through IP address space, then it doesn't really matter if you eventually list that IP address. If it takes you a month and the spammer has subsequently moved on to new parts of the IP address space, then this isn't going to do you much good. Okay, so here's what we did actually for this. We did a small study. We looked at our spam trap for about, actually two traps for about a month in March of last year. And then we looked at Spamhaus at the same time, and we said, okay, well, at the time these IP addresses sent spam to these traps, how many of those, was the IP address actually listed? And we looked at the fraction of spam that was coming from unlisted IP addresses at the time of receipt, at the time it actually came to the trap. So in the case of the first trap, it was something like 35% of the spam that was hitting the trap was not listed in Spamhaus. In the other case, it was only about 10. Still a fairly significant amount when you consider that you'd like none of this to be hitting your inbox. In terms of responsiveness, right, we can look at, how many of these IP addresses or what fraction of the corresponding spam was still unlisted, or was from IPs that were unlisted after a month, right? So still, actually, a month later, about 20% or about 20% of the total, about 2/3 of the spam that we saw at the time of the receipt was coming from IP addresses that were actually essentially never listed, right? After a month, they were still unlisted. Okay, so work to do. There's actually another way that we can look at this, because that was just Spamhaus, right? So you can actually ask, well, what does this look like for other blacklists, right? So I mentioned that we queried something like 8 blacklists for that longer study, and what we did here was to look at how many of these blacklists was this IP address listed in at the time the spam was received, right? So keeping in mind, actually, that some of these blacklists actually list very aggressively, right? We know some of these, like SpamCop, will list you for doing just about anything that looks like spammer behavior. Okay, so the interesting point here, so the way to read this actually is, this is the fraction of all spam that was received that was listed in N or more blacklists, right? So 100% of it, of course, is listed in 0 or more, right? And then 0 or fewer, right? So here we can say, okay, well, what fraction of the spam was listed in 1 or more blacklists, right? So if we look at the red line, that's all the spam that we're seeing at the trap. So there you can say about 80% of the spam that we received was coming from IP addresses that were listed in 1 or more blacklists, right? And about 50%, a little more than 50% of the spam was coming from IP addresses that were listed in 2 or more blacklists. Okay, so interesting thing to note there is there's basically still significant room for improvement. That's 20% of the spam is coming from IP addresses that were not listed in any of these 8 blacklists, even the super aggressive ones. Okay, so the other things that are interesting to note about this graph are the green line, which is a little tough to see, but let me trace it for you. That is basically, we're asking the same question, but just for the IP addresses that were part of this sort of BGP madness thing that I showed you before, right? So there, for those IP addresses, only about half of them were listed in any blacklist, right? So half of those IP addresses that were jumping around in those, those hijacked /8s were not listed in any blacklist at all. So clearly still some room for improvement. Well, what's going on? So as I mentioned, and as this sort of the BGP-related results with regard to the blacklist effectiveness indicate, is that there's some amount of ephemeral nature to the IP addresses of these senders, right? And that actually creates problems for maintainers of blacklists, right? If your list is just based on IP addresses that you know to be bad, but you're continually seeing new ones, well, you've got a lot of catching up to do, so to speak, right? The other thing, and this is actually something that perhaps some people here have things to offer as well, but something that we're quite interested in is these blacklists actually also often require a human to notice or validate that that a sender is in fact sending spam, right? So many of these lists do operate on some level of automated alarms, but still require some amount of validation. So another thing that we're quite interested in is with regard to the behavioral techniques is how much of this can actually be automated. I'm going to skip that because that basically just shows this 10% figure. Here's another reason why these blacklists may have a hard time keeping up, right? If we look at the amount of spam that each one of these IP addresses sent to this particular domain, so this is basically one spam trap domain. So on the y-axis we have volume, that's amount of spam we saw, and on the x-axis we have essentially how long, this time span over which we saw that IP address active in the trap, right? So this is basically, a little more than a year and a half out here, or I'm sorry, almost a year and a half out here, and this is 0, and that's log scale. So you can see that actually even the IP addresses that have been active for a fairly long time, most of them are not sending more than 50 or 100 pieces of mail to the trap, and it's fairly independent of how long the IP address has been active. So if you are an operator trying to actually decide whether or not this particular IP address is a spammer and warrants an alarm, then if the IP address is one of these fairly low volume IP addresses down here, then it may not even be sending at a volume that warrants any kind of alarm or report, right? So there may be that leads to some of the things that I'm going to talk about in just a minute, which is that some of these techniques may benefit quite a lot more from coordinated monitoring or observation than they are today. Okay, so what do we do about this, right? I've been spending the first half of the talk essentially complaining, right? We know content-based filters have a way to go, and now we know these IP blacklists also have a way to go. So what do we do? Well, one option is we could sort of, rip out the plumbing of the internet. We could think about how we, how we could get better notions of sender identity, right? So instead of just using this IP address as the handle for my reputation system, could we come up with some stronger notion of identity? And I guess you could put like sender domain keys and things like that in this category. But there are also proposals like HIP and various things in the IETF going on that look at how do we actually make us, come up with a stronger identifier for the sender itself. So that's an interesting direction. But as I mentioned, perhaps this requires, in many cases, significant changes to hosts, routers, and everything we know. So instead, what I want to talk about today are some sort of more immediate types of things that we can think about, which is, what about filtering based on sender behavior, right? We can do this today. The challenge then remains in sort of identifying what features best distinguish spam from legitimate mail. OK, so the first thing I want to talk about is, in this regard, is a system or algorithm, I should say, that we've come up with called Spam Tracker. This was joint with my student, Anirudh Ramachandran, who did a lot of the work on characterizing the senders as well. This is also with another professor at Georgia Tech, Santosh Vimpala. So the idea here was basically, starting off with this high-level idea about, well, let's come up with some kind of behavioral features that would allow us to put senders into buckets, if you will, or clusters that would identify them as sort of groups of, bad gangs, if you will, right? So the idea being that, well, the intuition that we went looking for was that maybe lots of spammers behave in similar ways because maybe they're using the same software, or they're part of a botnet, or for whatever reason, we're going to go look for coordinated behavior. OK, so here's the idea, right? So let's construct some kind of fingerprint for the sender, and I'll describe what that is in just a minute. And then let's cluster those senders that have similar fingerprints, right? So now I'm taking IP addresses, things I've seen before, and putting them into groups. And then when, if I can identify a group of those as being bad, then if I see a new sender, say it's a completely new IP address, well, that doesn't matter. Like if it somehow behaviorally is similar to something I've seen before in one of these bad gangs, then I can just say, OK, this is probably bad. I don't have to wait for reports of this particular IP address being up to no good. So the key question then is, two key questions. One is what's the fingerprint, and the other is how do we actually do the clustering. OK, so this was essentially a first crack. It works pretty well. It's not without some drawbacks. And I'll talk about some of those later, but let me just sort of describe the scheme first. The feature that we start with is let's look at the email sending volumes of each IP address across a set of recipient domains. So by domains here, I mean a name, like gotech.edu or google.com. Right? So what this assumes is the ability to observe an IP address or the sending behavior of an IP address across many, many domains. That sounds really hard, but in fact, it's not. Right? Because if you think about, put yourself in the position of a blacklist operator. That blacklist operator is getting queries from mail servers essentially all over the world, right? Thousands of domains. And those queries actually you can use those as an indicator of, that IP address or that domain that's querying me got email from this IP address that it's querying, right? So you don't have to have mail servers everywhere to actually be able to assemble this feature. So that's the feature that we start with. And then what we do is basically start building clusters around IP addresses that exhibit these features. So we start with some seed list of bad IP addresses, say IP addresses that we've already known to be bad, either because they're part of a botnet or because they're listed in Spamhaus or something, right? So for each of those, then we construct this feature across time, right? And then, or for a particular time window. Then what we do is collapse those features into a single matrix, right? So now each row in the matrix is an IP address, some sender, and each column is a domain. And then each entry in the matrix is the volume of mail that that IP address has sent to that domain over whatever time interval we've chosen. Then we throw some magic spectral clustering at this matrix, which I won't describe in this talk, but it's a PCA-based clustering, and here's essentially what we get out. So what we get out actually are these pretty white squares, which actually represent clusters. So what this is an IP. So what we get out is an IP by IP matrix, right? So this is pairwise, and the intensity of each pixel basically represents how similar, in terms of that similarity of those feature vectors that I described before, that is volume to each domain, how similar each pair of those IP addresses is to each other, right? So, for example, we can look at some row here and some column here, and the fact that this pixel is white indicates that those two IP addresses exhibited very similar sending behavior with regard to this feature. Of course, the diagonal is going to be white. The striking thing about what we see in this particular example, and there are many examples that look quite the same as this, is that many of these clusters are fairly large, right? So that basically indicates that there are large groups of IP addresses that for this particular metric are behaving in very similar ways. So that's promising, because what that suggests is that even as new IP addresses are continually coming along, chances are that a bad sender may fit into one of these clusters. Okay, so what do I mean by fit in? Well, basically what we do is for each one of these clusters now, we compute a single fingerprint, which is essentially, if you remember that feature I'm using, is volume of messages sent to each recipient domain. We compute an average vector for the whole cluster that is, that particular. Each cluster essentially has an average vector that represents sort of the average behavior for that cluster. And then we compute for a new sender how similar it is to that average vector. If it's similar, we drop it into that cluster. OK, so that's actually what I just described. So evaluation is actually tricky because if we had perfectly labeled data on which to train and on which to test, then we would already have the perfect spam classifier, or we would have maybe, I guess the other thing that would imply is lots and lots of humans at our disposal, which we don't have. So what we can do is actually train based on imperfect labels. That is, what some other spam classifier decided was, spam or legitimate mail, and then compare what this classifier got relative to what that other classifier said was spam or legitimate mail. Okay, so we basically did this evaluation relative to some logs that were labeled, and the way that they were labeled was, they were postfix logs that said, for each line, they of course provided all the information we needed as far as timestamp and sender and recipient domain, but they also said whether or not the mail was accepted for delivery or rejected, right? So if we know that it's rejected immediately, then we can be pretty confident that those are spammers. Now, if it's accepted, that could actually be either legitimate mail or a mistake, right? Something that was later caught by, say, a content-based filter. So the spam label is not entirely clean, but we make do with what we can. Something about 15% of that accepted mail is also spam. Okay. So the other so that's one thing that we can do to evaluate this. The other, the last thing we can do is, of course, to deploy it, and I'll describe that in a little bit where we are there. The other thing we can do is compare against what other blacklists are saying. So the other thing that we did is to look at pieces of, or senders actually, for which mail was, for which the IP address of the sender was not listed in Spamhaus at the time we gave it a high score, but was later listed in Spamhaus. And there were some of those cases also, which I'll describe. Okay, so here's basically where we are with this particular feature and with this clustering method. So what I'm showing here is actually the score that we gave to a particular piece of spam based on the sender classification for things that were labeled as spam, that is, things that were immediately rejected, and things that, I don't know, maybe this is spammy ham, right? There's a little bit of spam in there as well, as I mentioned. So the thing to note here is that we are giving consistently higher scores to things that were labeled spam as opposed to those that were labeled ham. There's still quite a bit of room for improvement here, because what we'd like to be able to do is draw some kind of threshold, right? We'd like to say, well, any sender for which we give a score higher than 0.5, we just want to toss away. That's clearly not possible here, because if we did something like that, we'd be throwing away 20% of legitimate mail. So we can't solely rely on this, but that does go back to what I said towards the beginning, is that this is probably just another mechanism that's complementary to other things that can be that are being used as well. So there's certainly room for improvement there, and I'll talk a little bit about other features as well that we're looking at that will probably do a little better as well. The other thing we looked at, as I mentioned, was how often can we detect things before, say, these manual blacklists, right? A key advantage to some of the things that I'm describing is that they're automated, right? We don't actually have to wait for any user to say anything about the fact that a piece of spam arrives. So what we did was look at some of that stuff up here in the pieces of mail that were accepted for delivery, but we gave really high scores, right? So up here, we either have wrong answers, or we have things that nobody else seems to, has reported as spam, but might actually be spam. So when we looked up in, in that 15% up here, what we saw was about, I think it was about 10% of those were later listed in Spamhaus, right? So it's hard to say exactly how many wrong answers we have up here versus just things that we got ahead of someone else or that no one else ever bothered to report. But it is somewhat apparent that we're catching things that other blacklists are not catching as well. So false positives still kind of a tricky question, something that we don't have the last word on yet. But I think ultimately it's hard to do that without a deployment, and I'll get to that at the very end. There are other problems, of course, with throwing aside the accuracy question for just a minute. The feature I mentioned, you're probably already thinking, well, couldn't senders, if they knew we were using this, evade it? And I think that's certainly true, right? So there are various things they could do, right? They could inject noise. They could actually change their behavior so that they didn't fit into one of these clusters, right? Well, maybe we should look for a more robust set of features, right? So that's actually what we're working on now, and I'll describe some of the things that we've done there, right? So in the hunt for a better set of features, actually, we're interested in several things, right? Of course, one is accuracy, right? The other is robustness, right? As I was just mentioning, these should be features that are hard to evade, or that in the process of evading them, the spammer becomes less effective in terms of the volume of mail that they can send or their ability to evade the filters. In addition to that, we'd like to be fast, right? That feature that I mentioned actually requires a few pieces of mail to arrive before we can construct the feature vector. So can we do better than that? Turns out actually we probably can. The other is we'd like to keep the overhead as low as possible, right? we don't want to have to look at messages, right? Still, as I mentioned at the very beginning. Even better would be we don't even have to accept the SMTP connection. We could just tell from from one packet, maybe even, that that this is a likely spammer. That sounds perhaps tricky, but it's in fact possible. So I'll describe some features that actually allow us to do that. Okay, so here's one feature that we started looking at that actually looks quite promising. And the heartening thing about this is that it's simple, and you don't actually have to look even at the SMTP connection to extract this feature. So what we did is looked at we took IP addresses of senders and receivers and mapped them geographically. And then we asked, how far is this piece of mail traveling, right? And then we separated those by spam versus ham. So this was a different data set. I should just briefly mention the way this was a data set from Secure Computing, and the scores were such that ranges of these scores suggested, okay, these are definitely spam. These are things that are gray. Things that they aren't particularly sure. Green was basically we're definitely sure that this is legitimate. So what we see actually is that about so this is for this data set too. So let me just briefly mention something there too. But for this data set, 90% of the legitimate messages traveled about 2,200 miles or less. Whereas if you look at the spam messages, it's almost like 70% of them traveled more than that. And this line also almost, it's not quite uniform at random, but it's certainly quite a bit less skewed than the legitimate mail. So I should mention, Makaram points out that this might actually look different for data sets that are not enterprises, right? So for something like Google, this might look quite a bit different. So the data set we were looking at here was for things like, as I mentioned, it's from Secure Computing, which deploys spam filtering appliances at enterprises, where maybe multi-site communication, or email that travels within a company may be much less likely to, to travel, very far distances. So in any case, operating with the data that we had, this actually worked very, very well. I'll show what it does when we throw it into a classifier. Just a minute. Okay, so here's another thing that actually looked very promising and actually is pretty intuitive as well, and also heartening because we don't have to look at message contents, and we don't have to have even seen anything from this sending IP address before we make a decision. We can do it at the first packet that we see from that IP address. The intuition behind this is well, from looking at the data, what we see is spammers tend to huddle together in IP address space. It's not uncommon to see a /24 where 200 of the IP addresses have sent spam in a short period of time, right? So the feature that, whereas, if you compare that to, say, legitimate sending behavior, you might expect to see, maybe 2 or 3 mail servers for an organization, but it's unlikely that you're going to see hundreds, in a very small network block. So the intuition was, let's ask, or our feature is going to be, what is the size of the IP range in which I see my k closest neighbors, right? So I can say, okay, well, how far are the 20 closest neighbors? So let's just look out here at the edge, right? And for, if you look at legitimate, senders of legitimate mail, that's actually quite a bit further, I guess, almost 7 or 8 times further, or bigger range, I should say, than the senders of spam. So that's another feature that we threw in, right? So it follows intuitively from what you would expect in terms of senders of legitimate mail and spam. We throw this and a couple other features into a classifier just off the shelf. The results I'm showing here are from decision tree, but we also threw them into an SVM and got similar results. Basically, there's about a 92% detection rate for about a, shall I say, 7% false positive rate. Now that sounds actually high, but I guess I should mention a couple of things. So what we're comparing against here is actually the secure computing scores, right? So again, we don't know ground truth in terms of what's really spam and what's really ham. What we're trying to do here is to say, well, suppose we could take like the lightest weight features possible, right? Like I showed you things that we could get from a single packet, having not seen anything before from that sender. If we just look at those, we can come within, well, I should say we come reasonably close to what they're able to do with, who knows what else they're looking at. We know they're also looking at content, but they're also looking up in blacklists, and they're doing a whole host of things. So for fairly lightweight features, we're able to do quite well. We started to take sort of a multi-layered approach to this and said, well, what if you could look at a little more, right? Like, what if we still didn't want to look at the message, but we could watch the sender for a little bit of time? And there are other features that look potentially promising. So one of the things we looked at is, what is the variance in message size for a sender across a day or across a longer period of time? So I think this was just across a day. And sorry, these are a little hard to read, but this is like between 1 and 10K. This is between 10 and 100K, and this is between 100K and a meg for the size of the message. And if you look at spammers, and I haven't shown the actual variance numbers here, but the variance of the message size that any particular sender sends, that's interesting. Hi, welcome. The variance of the message size of that any particular sender is sending is quite a bit smaller in the case of spammers than in the case of legitimate senders, which actually makes sense when you think about it, right? Because people like you and me may send anything from a one-line email to something with a PowerPoint attachment or what have you. Whereas if you're a spammer, part of a spam campaign, then those messages may vary for evasion purposes, but the overall size of the message may not be quite as variable. Okay, so surprising thing actually, and we're still looking into this, but including this feature and some of these others that require more history actually decrease the accuracy of the classifier that I was showing before, which suggests that the data set may be biased and that some of these things may be resulting in some overfitting, but that's something that we're still looking into. Okay, so I just want to take the last few minutes to say, what do we do next, right? As I mentioned, the true way to figure out how well these things are actually doing is to deploy them, right? And the nice thing about a lot of the algorithms that I've discussed is that we can run them based on just simple network level features. We don't actually have to see the contents of the message, which means we can actually deploy them, for example, as just yet another DNS-based blacklist, right? So a query to a blacklist that we're running could give us information, for example, about the domain that received the message, the IP address of the sender. Other things that we have looked at include time of day, et cetera. And some of these companies that build spam filtering appliances have come up with very clever ways of jamming other kinds of metadata into DNS queries. So all the things that I mentioned could pretty easily be jammed into those queries. The other thing, for some of these features, you might imagine doing something on the wire. But so just briefly, how this might look, right? As mail arrives at mail servers, those mail servers are going to generate lookups, or those spam filters, much like Spam Assassin would look up something in Spamhaus, right? Except now it would be us, right? So those queries then provide some proxy for what email behavior is actually existing, and then we can use information about that inference about those mails being sent to form the clusters that I was describing, and then also run the classifiers that I was describing, and then you return a score, much like Spamhaus would give you a score. As I mentioned, so work in progress is actually to deploy this system and throw the algorithms that I've described to you as a back end to that to see how well some of these things would actually work in practice. There are lots of questions that we hope to answer as we do that, right? So are we going to run into problems with, can we actually construct these signatures and scores quickly enough? How much data are we going to get in terms of lookups, and how much do we actually need to come up with legitimate classifiers as well. We'll see if we get attacked. Other things are, how many domains do we need to actually see before we can actually come up with some reasonable classifier. Okay, so covered quite a bit. But just to remind you, some of the things we talked about at the very beginning, which is just a study of some of the network level behaviors of the spammers, in the hopes that we could come up with a different kind of filtering approach, right? So based on our better understanding of those network level features, I've talked about a new sort of hopefully complementary type of approach to filtering, which is blacklisting these senders based on how the messages are sent, as opposed to what's in the messages themselves, or what the IP address of the sender is. I've described two separate algorithms for doing this kind of behavioral-based clustering, also based on different types of features. And the next step, as I mentioned, is to build them into this system that I described, see how well those things actually work in practice. So thank you for coming. Thanks for your time. And maybe there's a little time for questions.
So a lot of the things you describe are perfect mail list detectors. Mm-hmm. So there's legitimate mail that looks a lot like spam mail. So I mean, it addresses a lot of people over a large distance. How do you can't false positive on those things. That'd be bad.
That's true. Yeah, I guess the clustering approach might be more susceptible to that kind of mistake, right? Because you'd see one sender sending to a wide variety of perhaps odd-looking domains. So I don't know, actually, maybe in those cases you might have to do some whitelisting as well. So one of the things we did that helped that approach was to seed the clusters with known bad senders. So in those cases, that would at least give us a start on clusters that, or senders that were sending to odd-looking domains, and hopefully a mail list would not, exhibit some similar set of targets. But yeah, you might actually have to resort to whitelisting in some cases.
You mentioned that you could not trace route to a number of addresses. I remember 60 to 80%, right?
Right.
But it is fairly common on the internet. In fact, if you take an address at random, you'll probably be able to trace route to even less percent of addresses.
That's true, although in this case we weren't trace routing to just arbitrary IP addresses. Mm-hmm. We were trace routing to IP addresses that we knew at one point had actually completed a TCP three-way handshake with us, right? Mm-hmm. So one would expect that,
But even in that case, from my previous experience, I know that the percentage may be lower.
Well, so one reason it might be lower is because like the host that connected to us is behind a firewall. Yeah, right, so that's why actually I didn't give a precise number. Mm-hmm. It's because in many cases it was hard to tell, okay, is this actually unreachable, or is it just that the host is firewalled, right?
Or its network is dropping ICMP.
Yeah, although what we did there is to say like, okay, well if it got at least to the subnet, we would say, okay, it's probably still reachable in some sense, right? Because what's being announced and withdrawn in these cases are /8s, so, right? If that /8 is,
But the phenomenon of announcing and withdrawing of /8s was around since at least 10 years. Jeff Houston has, by the way, also shown it in his plots of available routed address space. It's not today's phenomenon.
Right. So you're right. This has been going on for some time. Actually, I don't know. In his study, did he do any correlation with traffic? Because I don't know.
No, he just has shown that it is oscillating essentially.
Right.
Those same address blocks that you mentioned.
I'd be curious to see actually why those others. If they relate to this at all,
might have been the same reason actually back then.
It might have been the same reason back then.
Because I saw it back in the 90s. That was also announced and withdrawn. Very large address blocks that obviously don't belong to small ISs.
Right.
That announced them.
Right. Yeah. So it might have been going on for quite some time before this. It's probably likely, in fact. Yeah.
So
Yes.
if you actually find that the very first packet it is from a spam, and do you just reject the connection immediately?
That's a good question. In fact, I don't have a good answer to that. I mean, obviously there are a number of things that you could do, right? You could drop the connection. You could graylist. You could, accept the mail for delivery, but give it a higher score for, a later filter. And I think actually some of those questions I don't have good answers to yet, because that ultimately boils down to it's a strategy question in terms of like, well, what is the cost of, dropping a connection and forcing someone to resend? Maybe you don't want to ever do that, but
because if you actually drop the connection right away, the spammer kind of like know that you must be detecting the spam at the network level, so you haven't even seen the content. So it's kind of like a quick feedback of how he should alter his sending behavior to penetrate this system.
That's true. In fact, I mean, in the cat and mouse game, the spammer may detect this and then do something different. However, I mean, at least today, I wouldn't expect them to do that, just based on, I mean, the only evidence we have so far on that front is graylisting, right? And this tends to work because if you ask the sender, if you ask the spammer to come back at a later point, they typically don't, right? So you're right. If they start to use more sophisticated approaches, then they may catch up to that as well. On the other hand, even if they could detect that you're doing that, there's the next question of like, how would they respond? And hopefully we could come up with some features that, even if they knew we were doing this, they couldn't do much, right? Yes.
I've wondered if you thought about using this technique to automatically generate sort of a global whitelist. It seems to me that the total number of MTAs, although it's a very large number in many organizations, is now within the easy access for a database, and you could find things that look like it's ham and mark those as being legitimate MTAs, and then everything else is a suspect.
Okay, so actually I think some of the approaches could be used for auto whitelisting. For example, the clustering approach might work very well, because if it's a set of mail, like MTAs being used by a company, similar set of users, then chances are they're going to exhibit similar behavior. So I think that could work pretty well. I haven't actually tried that, but I think that could be quite promising.
So I guess my question is sort of the inverse of that, which is you mentioned a few times in your talk about the concerns about figuring out in advance how to deal with dynamic addresses, and I can point out that Sorbs, which is one of these popular blacklists, actually listens for all sorts of traffic, just indicating a compromised machine. They don't wait to hear spam. They just look for evidence of compromise, and if they see compromise, not only do they blacklist host IP addresses, but they also are very willing to expand to a CIDR prefix that's larger than that IP address, like a /24, a /16, et cetera, in the hopes of putting the pressure on ISPs to take some responsibility for their content. So in light of that, my question is, how can we respond to the spam problem without pressuring ISPs to take too much responsibility for what traffic flows through their network? And you alluded to DKIM as well before. I mean, we can see that discourages people from running mail servers, and these kinds of whitelists also discourage people from running mail servers. So how can we respond? How can we respond without saying, look, only a privileged elite can run mail servers?
I see. So the question is, how do you make it possible for just like arbitrary people to run mail servers without just leaving things wide open? Is that the question?
That's part of the question,
okay.
Yes. Another part of the question is, how do we not cause ISPs to be on the hook for all the traffic that transits their network?
I don't know how to answer the second one, but to the first one, certainly I think so that's actually a big motivation for like doing this kind of behavioral approach, right? Because the disadvantage to saying the whitelists as we know them and DKIM and things like this is that you have to go through an administrator or an operator to actually get these things set up. And it's, even SPF is a bit of a pain. I can't even get it set up for the server that I send mail from often. So if you have to rely on those things, then yeah, there can be a bit of a barrier. If on the other hand you're doing this type of thing, then sure, you can just fire up your mail server and then rely on hopefully you're doing things that don't look like something that a spammer might do. The disadvantage, of course, being that it's not rock solid, perfect, right? I mean, with DKIM or SPF or one of these things, like you have a higher level of confidence that you're not going to, have false positives. Whereas here, the chances of misclassification are probably higher, but you gain flexibility.
So you're saying that this work does fit into that patchwork of empowering.
I think it's a different point in the design space. Yeah, it fits. It definitely fits into that patchwork of empowering the arbitrary user. I guess you could say. Right?
Thank you.
Yeah.
Thank you.
Thanks.